Okay, so question number 4. What is the Lewis structure of xenon tetrafluoride? Also indicate whether it is polar or nonpolar. Okay, so we have xenon tetrafluoride. So to find out the Lewis structure, I'm first going to calculate the total number of valence electrons in the molecule. So xenon, the xenon atom has 8 valence electrons, and a fluorine atom contains 7. And since there are 4 fluorines, we multiply that by 4. And if we add it all up, we should get 36 valence electrons. Okay, so now I'm going to draw out my structure. So assuming xenon is our central atom, I'm going to draw xenon in the middle, and then just the 4 fluorines all around it. And then I will draw in all of their lone pairs. Okay, so it's this point in drawing where I like to count how many electrons I've drawn so far. So if we remember that each bond contains 2 bonding electrons, and we have 4 bonds, so that's 8. And then each fluorine atom has 6 valent electrons. So 6 times 4 is 24. So we have 32 electrons drawn so far. So I need 4 more if our total valence electrons is 36. So I'm just going to draw in my last 4 electrons as lone pairs on xenon. So now this is our molecule. And the second part of the question asks whether it is polar or nonpolar. So I'll just take note down here that the xenon-fluorine bond is polar. But if we look at the overall molecule, where because fluorine is much more electronegative, I can show dipole moments all pulling electrons towards the direction of the fluorine atoms. But since this molecule is symmetrical, all of the dipole moments cancel each other out. So the xenon tetrafluoride molecule as a whole is nonpolar. So its geometry is a square planar, and it's also symmetrical. Okay, so let's see what the junior tutor said. Okay, so they have the same Lewis structure. Xenon has 2 lone pairs using AXE method to determine geometries, which I think is also just the Vesper theory. AX4, E2, I think, which corresponds to a square planar molecule. Square planar molecules are symmetrical, therefore xenon tetrafluoride is nonpolar. Okay, so this solution is correct. The dipole moments in the xenon fluorine bond will cancel each other out.